So
Yes.
so we have to place something
Yeah, copy it, right? Yes, just wherever you want, you can copy it wherever you have space, and then afterwards you just need to double click on this 3 KB icon. It will open up in your mesh. Okay. Wherever you have space, you can copy it. You have in C drive, D drive, that's your choice. And just double click on this icon, it will get opened up. Alright, so let's begin with Mapreduce. Okay, so we'll be doing Mapreduce, we'll be doing Pig, Hive, all we will be discussing first, and we'll be doing then practically how to make applications on Mapreduce, how to write Hive queries, how to write Pig Latin scripts, all that we will see. Fine. So let's begin with Mapreduce. Okay. So what is your understanding of Mapreduce till now? What do you understand by Mapreduce? It is a processing layer of Hadoop. Okay.
it works in parallel with
It works
parallel.
parallelly. You are writing something? No. Okay. No idea. You have written this? Akshar. Okay. Fine. Do you remember that example which I gave for Mapreduce? Right? If you invite your friends and you find a lot of, okay, more than expected. Fine. Okay. So as you said, yes, Mapreduce is a programming paradigm. Okay. What is a paradigm? You can say a kind of programming practice, a technique. Okay. And whole of Hadoop, which was developed for processing Hadoop, only had, I'm using the word had, Mapreduce as a processing technique. Okay. For storage we have SDFS, right? Hadoop Distributed File System. And for processing, Mapreduce was the only technique or type which Hadoop was having. Okay. Fine. So let's discuss about it. We have seen that components which are involved in Mapreduce processing, okay, will be job tracker and task tracker. We know, right? Job tracker and task tracker. And because our data is stored in data nodes, right? So because the data is stored in data nodes, so data nodes are also a part of Mapreduce because data will be fetched from data nodes. And how that data will be fetched, that is all managed by name node. Name node manages how the data is getting stored in the data nodes. Okay. So job tracker will need some help from the name node in order to process some program over some data. Okay. So here you can see we have a name node, we have job tracker, we have data node, we have task tracker, and one more component written there is client. Secondary is not there. Client. Okay. Secondary name node, you know, it helps name node to update the meta information, right? Yes. So client is another component written there. So what is the role of client? Someone has to submit the job, right? Someone has to submit the job. So job can be submitted by just using your shell terminal. You can write some application and you can submit a job by writing some command, as I had shown you while doing benchmarking. So that was a job basically. Okay, so how did I submit? I had written a command and job was submitted, right? While doing benchmarking, it was a job actually, right? So job can be submitted from a shell. Job can be submitted by some other application. As I told you, we will be discussing about Pig and Hive as well. So if you are basically writing some pig script, pig Latin script, and if you execute it, so that job is ultimately going to your Mapreduce. It is getting converted into Mapreduce and it is executed by the job tracker only. Okay, so at that point of time your pig becomes a client, because via pig shell you are submitting a job. If you are doing something in Hive, you are writing some queries and you are making some joins, or you are putting some where clauses. Again, you are writing queries in Hive, so the job is getting submitted by Hive shell. Are you able to understand what I am saying? Pakka? Okay, right? Yes. So client is that particular tool or some software which is submitting the job. Okay, it can be anything. Okay, fine. So these are the components which are involved. Now let's move on the next. Okay, this is a general flow, how exactly Mapreduce is getting executed. Okay, so client submits a job to JT, that is job tracker. Then job tracker confirms the addresses with the name node. Name node provides JT with DN addresses. JT allocates tasks to task tracker, giving preference to local DT. Okay, so I have just read it. I don't know whether you have understood or not. Okay, so the step one is, I told you that some client has to be there which will submit the job. This you must have understood, right? Step 2 is JT, that is job tracker, conforms with NN. NN is your name node. So job tracker conforms with your name node. What does it confirm? Because it needs to process, so it needs to know like where is that data, and mapping of data, like in which data node data is residing. This is only known to the name node, right? So name node is like brain or memory of your whole cluster. So job tracker takes help of name node, that where is the data, and name node will tell data is present in node 1, 2 and 3. Okay, this way job tracker will get to know from name node. Okay, then what job tracker will do next is JT allocates tasks to task tracker. So task tracker is that particular unit, a slave unit, right, which actually executes the program. Okay, so job tracker is the coordinator, job tracker is the master component. So job tracker will identify node 1, 2 and 3. Node 1 is also having task tracker, node 2 is also having task tracker, and node 3 is also having task tracker. I hope you understand these things now, right? Every machine will have task tracker. And which other service? Wrong. Data node. A slave machine will only have two services, data node and task tracker, data node and task tracker, and in the node 3 as well, data node and task tracker. Okay, so understand this thing. Data node service will manage the data there in that particular machine, and task tracker service will help the job tracker to process that data which is managed by data node. Is it clear? Right? Yes. So job tracker now identifies 3 nodes, and now it will pass on the program, that particular job, to those respective task trackers present in those machines. Okay, and those task trackers will start processing. Okay, this is high level flow how exactly Mapreduce happens. Okay, now Mapreduce is basically will get executed in phases. Okay, it's not just a sequential program, because by now also you should understand that there also task tracker is working in node 1, in 2 also, in 3 also, and all of them will produce some output, but that's not the final output, because final output should be combined and given together. Okay, so again at high level understand this thing. When parallelly 3 task trackers are working on 3 different nodes, that is your map phase. As soon as they produce some output, that is the output of your which phase? Map phase. And then basically your second phase will start, and that is reduce phase. Okay, so in reduce phase, job tracker will again identify some task tracker. It may be out of these 3 only, it may be some other task tracker. So the job of that task tracker would be to collect the output from these 3 machines and aggregate it. So in reduce phase also, it may happen only one task tracker is working, or as per requirement more than one task tracker can be involved in reduce phase as well. Is it clear now? Right? So now, as of now, you understand that there are 2 phases in which the whole Mapreduce works. Okay, fine. Now here you can start again with the presentation. We'll go. As I said, initially we have data. We have understood the flow, how data actually gets stored in the form of blocks. So if you have data, then your data will be present in data nodes in the form of blocks. I am considering a block size with 64 MB. Okay. These days block size always comes up with 128 MB. Remember that. Okay. So here in the presentation 64 has been considered. Okay. So let's say multiple blocks are present in different data nodes and the block size is 64 MB. Okay. And we want to process on these blocks only, right? Okay. This is the flow of first phase, that is map phase. Okay. So in map phase what happens? Your 64 MB block is residing or is present in a data node, right? In some data node it is present, right? Second is that block is taken into the memory. Okay, because whenever we want to process something, that particular data set is taken in the memory, okay, for processing. So now here let me introduce the first component which acts when you perform a Mapreduce job. There is a component called as input split. Okay, so this input split is actually responsible for taking that particular physical 64 MB block into the memory. Okay, so let's say your 3 tasks are running in 3 different machines. So there will be individually on one machine input split will be invoked, another again invoked, another and again invoked. Okay, so 3 input splits will be there and one input split will take its own 64 MB of block. Is it clear? And that block is getting loaded in the memory now and it is ready for processing. Now after input split the second component comes, okay, that is called as record reader. The second component which is called as record reader. So as its name is there, record reader, so it reads the record. Okay, so whatever data that 64 MB block is loaded in the memory, so that block has got some data. That data is identified in the form of records. Okay, records can be, let's say we have 10 lines, so each line can be a record. Let's say we have 10 files, so each file can be a record. Okay, so how to define a record is a different thing. Okay, but yeah, with some mechanism that record reader will read whatever number of records are present in that particular block, okay, one by one, and as soon as it will read, it will pass that record to the mapper. So mapper is the actual logic, what exactly you need to do with that particular data. Okay, that's the actual logic, mapper. Okay, so record reader reading one record and passing it to the mapper, reading another record, passing it to the mapper. This is what record reader is doing. Now in mapper, whatever logic is there, that logic will get implemented. The important thing to understand is Mapreduce handles the data in the form of key value pairs. Okay, so Mapreduce, whatever data is coming, it will be handled in the form of key value pairs. So your record will also be a key value pair. Your one record will also be a key value pair. Okay, so record reader identifies a key and value, that is one record, and passes it on to the mapper. Identifies another record, passes it on to the mapper. This is what record reader does. Now there is another phase before your reduce phase starts. This is important, right? Before your reduce phase actually starts, there is another phase which is called as shuffle and sort. Okay, so just remember there is one phase. We will discuss this with an example. Okay, so this phase actually prepares the data the way it should go to the reduce phase. Okay, are you getting it right? So this phase is basically for organizing and preparing the data. Which data? Which is output of map phase, that data. Okay, so the output of map phase is organized with the help of shuffle and sort, and that is sent to the reducer. At this phase only, it is determined or it is estimated that how many number of reducers will actually get started. That means how many number of tasks will get started at reduce phase. Okay, at this phase only we will get to know. Okay, we'll discuss on it. Now then comes the reduce phase. In reduce phase, the data is again coming in the form of key value pairs only. Okay, so it basically aggregates or sums up that particular data. Okay, as I said, mapper's output is not the final output. Okay, so that something we have to do. Maybe just we have to club it together and write it in a single file. maybe least operation can be this much, okay. Or it may happen that we may have to combine two outputs of map phase and we will get one output. So there can be multiple calculations, multiple logics in reduced phase, or very simple logic, but some kind of aggregation is there, okay. Some kind of combining of the output of map phase has to be there, right. Then basically after that logic has been implemented, then there is a record writer. The way we have record reader in case of map phase, similar way here we have a record writer, okay. So this record writer, what it will do, it will basically write the data record by record. Again I am saying record is a pair of key and value, okay. So in key value form the output will be written on SDFS back, okay. Just remember, initially the data was in SDFS in the form of 64 MB blocks. Finally the output is again stored in the 64 MB blocks in SDFS. The intermediate output produced by mapper phase is stored in the local machines. That is not stored in the SDFS. Okay, so just remember this thing. So map phase output is written in the local machine because it is temporary. As soon as that whole output has been transferred to the reduce phase, that temp folder gets empty, okay. So that is temporary data, okay, fine. So let us take one example. Here you can see that refund, tax, bill, invoice. So this is one block, and then again refund, tax, bill, invoice, that is second block, okay. So consider this as first block, the first stanza I can say, and second stanza para can be the second block. So these are 64 MB blocks stored in SDFS, okay. And now as I said, the first component in Mapreduce is input split. So that input split will help us to fetch this block in the memory, okay. Is there any kind of doubt, or is everything clear till now? Clear or not? Okay, fine. Yes, so input split will fetch this block in the memory, right? So two blocks are now fetched with the help of two input splits. That means two tasks are running, right? Okay. Now basically comes record reader, right? So record reader will identify a record. So it is identifying a record. So one line is a one record, second line is second record, okay. So it is identifying a record and passing it on to the mapper, passing it on to the mapper, okay. So this is happening parallelly. Okay, on one machine it's happening, on another machine again the same thing is happening, okay, with the another block. Clear, right? Then now what happens in mapper, we have an objective of counting that how many times refund has been asked, how many times tax is happening, okay. So we are counting the occurrence of a word, okay. So in mapper the logic which I have written is that let us basically split the words refund, tax, bill, invoice. Let us split the word and we will assign a weight to each of the word, and weight will be 1. The value of the weight will be 1. So we have assigned refund 1, tax 1, bill 1, invoice 1, discount 1, okay. So to each word we have assigned a weight, okay. So similar thing will happen with the second line also, right? What is the second line? Tax, refund, bill. So tax 1, refund 1, bill 1, okay. So for every record this will happen. So this is the logic inside mapper which we have written, okay. Clear, right? So mapper is giving an output of this kind, refund 1, tax 1, okay. As I said, here also the data is coming in the form of key value pair, but I haven't mentioned there, okay. I haven't mentioned, I'll just tell you verbally. So this refund, tax, bill, this is actually a value, this is value, okay, and there is a key. So in this case the key is the address of that particular line, okay. Just remember this much only as of now, okay. The address of that particular line is the key and the whole line is your value, okay. Then basically we had nothing to do with the key. Key was of no relevance to us as of this example, okay. So what we did not consider the key here, we just took the value and we did split those values and we have assigned a weight 1 to all those values. Now basically the output is again in the form of key value pairs. Now the key is your refund is key, 1 is value, tax is key, 1 is value, this is key, this is value, okay. So your word is your key and that 1 is your value. So this is up to us that in which space what key do we need to generate and what can be the value. This is up to the developer. Okay, fine. Now next, so this is how we will get, okay, for all the files, let's say there were 3 files or 4 files, whatever number of files. So for 1 we are getting this way, for 2 we are getting this way, for 3 we are getting this way. Okay, refund comma 1, tax comma 1, refund comma 1, this way we are getting. Okay, as I said, there is a phase called as shuffle and sort, which will prepare the data for the reduce phase, right? So what shuffle and sort does, there are 2 words, shuffling and sorting. 2 things are there, right? So sorting is basically organizing the data in the form of sorted order with respect to the key. So key here is refund, tax, bill, that is the key. So with respect to the key, the data will get sorted. Okay, so here you can see data is getting sorted, bill, discount, invoice, refund, tax, it is getting sorted. Okay, so after it is sorted, then shuffling is performed. And what is shuffling? You will understand in the next slide. This is shuffling. Okay, are you able to understand what's happening? I'll tell you. So shuffling basically means, now I said that at the phase of shuffle and sort, it will be decided that how many number of reduced tasks are to be invoked, are to be started. Okay, so how is it decided? It is decided on the basis of the unique number of keys you have. Unique number of keys you have. Your keys are bill, tax, invoice, refund. These are your keys. Okay, so bill is one, discount is another, invoice is another, refund is another, tax is another, bill is repeated, discount is repeated. Okay, so in total 5 keys you have, right? 5 unique keys you have. If it is repeated, then it will be considered for the first reducer only. Bill is repeated, it will be considered for the reducer for bill which is already allocated, right? So we will have a reducer for bill, a reducer for discount, a reducer for invoice, a reducer for refund, a reducer for tax. So altogether 5 reduced tasks will be there. Are you getting it? How the number of reduced tasks are defined? Did you understand? Right? On the basis of? On the basis of? You didn't understand. On the basis of? What happened? Unique keys. Unique keys. You should repeat it then. Why are you confused? Right? You should repeat the same thing if you are right. Okay. So on the basis of unique keys, okay, which we are getting on as an output of map phase, right? Okay. So now shuffling means bill from here is coming to this place, discount from there is going to this place. So this is shuffling. Are you able to understand? One output going to this place, another output going to this place. This is called as shuffling. We are shuffling the output, right? So shuffle and sort phase takes place before reduce task actually starts. Okay. Shuffle and sort phase is counted in reduce phase only. Is it clear? Shuffle and sort phase is counted under reduce phase only. Okay. Map phase ends as soon as it gives output. Okay, that is the end of map phase. As soon as shuffle and sort phase starts, that is counted under, the time is, that percentage is counted under reduce phase only. Okay, yes. So this is how reducers getting the input from shuffle and sort phase. And what is the input? It is getting bill and 1. Then from there also bill and 1. From there also bill and 1. This is how it is getting. Okay. So what is happening here? Alright, so one reducer, if you see, okay, one reducer, it is getting bill comma 1, bill comma 1, this way it is getting the inputs. Okay, and how does it store? Okay, it stores this way. Bill is the key, 1, 1, 1, because 3 times it has come, so it need not to store bill multiple times, but it should store 1 multiple times, the number of times it has got that input. Okay, so bill, then 1, 1, 1, 1, 1, so that is collected in a data collection, okay, collection data type, okay. And then basically we write a logic to sum up this one, and this one is all the ones are summed up and we get 3 as output. So bill is key and that output is value. So that is written by record reader in the SDFS. Clear, right? So this is how actually Mapreduce works. Okay, internally what exactly happens? Now I think you got the picture of that, right? Okay, this is another example. Okay, another example, that is inverted index example. Let's say you have you use books, right? Reference books or any book you use, and you go back and you will find some glossary, or that is called as inverted index. You will find certain words, and that word in front of that you will get page number or chapter number, that this word occurs on this particular page number or chapter number. Okay, so there is an index which is which is in the at the beginning of that particular book. Apart from that, there is an inverted index or glossary, okay, where some technical words are written, and in front of them page numbers or chapter names or page numbers are written, that this particular word is present in this page, okay. And that becomes easy for us to basically, because index will not contain all those words, right? That is called as inverted index. So let's say you have a file. In first example I told you that the key was the address, which is also called as byte offset, okay, and the value was whole line in the first example, right? That was the occurrence of word. And in this example your file is basically like this. Your file is chapter 1, chapter 2. Chapter 1 you have 1, line number 1, 2, line number 2. So inside only it is written line number 1, 2, 3 inside the file itself, okay. So if it is written inside the file itself, then it becomes easy for us to understand. What to understand? To understand that 1 can be key and rest of the line can be value. 2 can be key, the rest of the line can be value, okay. Instead of considering the byte offset, it is easy, okay. So here basically we will have another kind of key value pairs, okay, another type of key value pairs which will get into the file itself, and from inside the file, from the data only, it will identify key and value, okay. So whatever is the separator, like here if we are using a tab or we are using whatever separator we are using, space, so we'll have to define that the first value is key and then there is a space and rest of the line is value, and then you will find a new line character. Again the first will be key, then there will be a space, so that will have to define, okay, fine. So what will happen now? Now basically we'll have two phases, right? Again map and reduce phase. So here what logic can be done? In map phase, this is the expected output. Here you see this is the expected output, that refund, this is refund. So refund occurs chapter 2 at the rate 1, chapter 2 at the rate 1, okay. Then tax is there, tax, so it is chapter 1 at the rate 2 and chapter 2 at the rate 2, okay. So this is a kind of output which we should get. So let me give it as an exercise to you, that how will you write logic in map phase and how will you write logic in reduce phase. You just have to write an algorithmic way, okay, how you will organize the logic of this into map and reduce phase, okay. So let me give this as an exercise to you. Yeah, so this is the solution, but I'll not show you, okay, fine. Is Mapreduce concept clear, right? Okay, now let us move to the next concept, that is Apache Pig. So that exercise you have to do and